Hi there, and welcome back to VCE Master Academy. Today we are going to learn how to stretch, squeeze, slide, and lift our sine, cosine, and tangent waves. All of it is controlled by just four numbers in one formula. Y equals A times f of bx plus c plus d, where f is sine, cosine, or tangent. Think of A, B, C, and D as four dials. Let us turn them one at a time. The first dial is A. This is the amplitude, how tall the wave is. It stretches the wave up and down. The amplitude is the size of A, written as the absolute value of A. And if A is negative, the wave flips upside down. The second dial is B. This changes the period, how long before the wave repeats. For sine and cosine, the period becomes 2 pi divided by b. For tangent, it becomes pi divided by b. A bigger b squeezes the waves closer together. The third dial is C. This slides the wave left or right. We call it a horizontal shift or phase shift. To find the shift, factor out b so it looks like b times bracket x plus c over b. The wave moves by minus c over b. A handy tip: if you see x minus something, it moves right. X plus something, it moves left. The fourth dial is D. This lifts the whole wave up or down, a vertical shift. The middle of the wave, called the center line, moves to y equals d. Here is our first transformation. This is y equals 2 sine x plus 1. The 2 makes the wave twice as tall, and the plus 1 lifts the whole thing up by 1. So the center line sits at y equals 1. The top reaches 3, and the bottom reaches minus 1. Now, how do we read the range quickly? The center line is y equals d. From there, the wave goes up by the amplitude and down by the amplitude. So the maximum is d plus the size of A, and the minimum is d minus the size of A. The range is everything in between, from d minus the size of A to d plus the size of A. Here is a second one. This is y equals 3 cosine of 2x minus 1. The 3 makes it 3 tall. The 2 inside squeezes the period to 2 pi over 2, which is pi. And the minus 1 drops the center line down to y equals minus 1. So the top reaches 2 and the bottom reaches minus 4.
Example 1. Nice and gentle. Look at y equals 2 sine x plus 1. The amplitude is 2. The period is 2 pi because b is 1. The wave is lifted up by 1, so the center line is at y equals 1. The range goes from 1 minus 2 to 1 plus 2. That is from minus 1 to 3. Example 2. Medium. Look at y equals 3 cosine of 2x minus 1. The amplitude is 3. The period is 2 pi over 2, which is pi. The center line is at y equals minus 1. So the maximum is minus 1 plus 3, which is 2, and the minimum is minus 1 minus 3, which is minus 4. The range is from minus 4 to 2. Here is our third transformation, using all four dials. This is y equals 2 sine of 2x minus pi over 3 plus 1. To see the shift clearly, factor the 2. It becomes 2 times, bracket, x minus pi over 6. So the wave is shifted to the right by pi over 6. The period is pi, the amplitude is 2, and the center line is at y equals 1. Example 3, an ATAR style one. Take y equals 2 sine of 2x minus pi over 3 plus 1. The amplitude is 2. The period is 2 pi over 2, which is pi. For the horizontal shift, factor out the 2 inside. 2x minus pi over 3 equals 2 times, bracket, x minus pi over 6. So the wave moves right by pi over 6. The plus 1 lifts the center line to y equals 1. So the range is from minus 1 to 3. 4 dials, 4 effects. Stretch, squeeze, slide, and lift. Where does this show up in real life? Tides are a perfect example. The height of the water can be modeled by a transformed sine wave, like height equals a sine of something plus d. Here d is the average water level, the center line,
and A is how far the tide rises above and falls below it. A Ferris wheel works the same way. D is the height of the center of the wheel, and A is the radius. Quick summary. In y equals A, f of bx plus c plus d, A is the amplitude, the size of A, and a negative A flips it. B sets the period, 2 pi over b for sine and cosine, pi over b for tangent. C gives a horizontal shift of minus c over b, and D gives a vertical shift, moving the center line to y equals d. The range for sine and cosine is from d minus the size of A to d plus the size of A. Now it is your turn. Pause the video and try these 5. 1. State the amplitude and period of y equals 4 sine of 3x. 2. State the range of y equals 2 cosine x plus 5. 3. State the period of y equals tangent of 2x. 4. For y equals 3 sine of 2x minus 1, state the amplitude, period, and range. 5. Describe the transformation in y equals cosine of x minus pi over 4. Ready? Let us check them together. Question 1. For 4 sine of 3x, the amplitude is 4 and the period is 2 pi over 3. Question 2. For 2 cosine x plus 5, the center line is at 5 and the amplitude is 2, so the range is from 3 to 7. Question 3. For tangent of 2x, the period is pi over 2, because tangent's period is pi over b. Question 4. For 3 sine of 2x minus 1, the amplitude is 3, the period is pi, and, with the center line at minus 1, the range is from minus 4 to 2. Question 5. Y equals cosine of x minus pi over 4 is the cosine wave shifted to the right by pi over 4. Fantastic work! You can now stretch, squeeze, slide, and lift any circular function using the 4 dials A, B, C, and D. Remember, you are mastering VCE Maths, one concept at a time. I will see you in the next lesson at VCE Master Academy.